when we talk about how tangent works, what I want to do is kind of go back into our unit circle and look at what's occurring with tangents. So when we talk about the unit circle, let's see. Tangent was what over what?
Opposite over adjacent.
Okay, in terms of x's and y's, what was tangent? Sine over cosine, so it's y over x. So as we're going around our unit circle, our quadrantals gave us 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Do we agree?
Yes.
Now, as we're going around, this means this is at 0, pi over 2, 0, pi, and then 3 pi over 2, and then back up to 2 pi, going full way around. There was also a special position for tangents that always equaled 1. Where did tangent always equal 1? Do you remember? At the 45-degree angles. So at the 45s, it was always, what, pi over 4? 45s is always pi over 4, and tangent was root 2 over 2, root 2 over 2. So the tangent always equaled 1 at pi over 4s. So it was positive 1 here, negative 1 there, negative 1 here, excuse me, positive 1 here, and then back to negative 1 there. So as you're going around, remember, at the 45 degrees, at the multiples of pi over 4, tangent was either 1 or negative 1. Where was tangent undefined? At the what?
On the y-axis.
On the y-axis. Remember, it's going to be when cosine, or excuse me, when the x value is equal to 0. Tangent is undefined at pi over 2 and 3 pi over 2. You have 1 divided by 0, so you get an undefined value. When you're graphing something and you have a 0 in the denominator, what did you guys always draw at that value? Remember where you graphed rational functions? 2 over x minus 2? We had an asymptote. You had an asymptote at certain values where you had zeros in the denominators. Works the exact same way with tangents. When we're graphing out tangents, you wind up with asymptotes at your multiples of pi over 2. Basically, that means that every time you get to a pi over 2 with the tangent, you're going to get an asymptote. You cannot, it cannot occur. I agree. So here's what tangent looks like. If we take the regular XY grid, I know that the tangent of 0 is how much? Go back here. What's the tangent of 0? It's 0 divided by 1. What do you get? 0. So at 0, 0, tangent is 0. The next value that I know that tangent occurs at, that's easy to graph, is at pi over 4. Do you agree? At pi over 4, what's tangent equal to? 1. At negative pi over 4, what's tangent equal to? Negative 1. Now, what occurs at pi over 2? We get the asymptote. At pi over 2, you get an asymptote. So what happens at negative pi over 2? An asymptote. Now, if I'm looking at the curve for tangent now, going from left to right, what is it doing? Yeah, it curves. It's increasing. So the curve of tangent is nothing more than plotting these 3 points with this. Now, look at the graph. What's the period of tangent? Pi. It's pi. How far apart are the asymptotes?
Pi.
Pi. How are you?
Sorry.
2 up like 5.
No. So the period of tangent is always going to be pi. What happens is that these asymptotes in this curve continue, it does the same thing every single pi period, if you will. Tangent, if the a value of tangent is positive, it's always increasing, goes through the origin. At multiples of pi over 4, it's either going to be 1 or negative 1. Works every time. Tangent really is very simple to graph. Again, the weird part's going to be working with the period and those shifting points as we get to it. Okay. Yes, sir.
Where exactly did you get the zeros divided by 1?
The ordered pairs and the quadrantals.
Yeah.
When you're talking about here, tangent is 0 divided by 1, y over x.
Oh,
I
yeah.
was just using those values there.
Okay.
Okay. That's how I've been working through all of these things. So that's how this stuff works, guys. It's very, very straightforward. There's no craziness involved. The weird part, like I said, is going to wind up being when we worry about how tangents, amplitude, and period is defined. So let's look at the generic form before we do the shift. Y equals a tangent b of x. This a value, there's really no, what you want to call amplitude. It doesn't have a specific height part of a curve or a low part of a curve, because the curve is never going to have a maximum, or it's never going to have a minimum, because it's always going towards that infinite, towards that asymptote, that was called. It's always approaching that asymptote, but it won't get there. So it doesn't have a maximum value, but it has these points here and here are like the points of inflection, you'll hear them called, where it's changing direction. Those are these three critical points, some books call them. You might hear it worded like that. Excuse me. So we have this a value is usually where these points are going to occur. So if the a value is 2, means at pi over 4 it's at 2. The a value is 6, at pi over 4 it's 6. Things like that. And as we do a couple of examples, you'll see how it falls into place rather quickly. The b value, again, is going to help you find your period. The period of tangent is always going to be pi divided by the absolute value of b. I think I had all this written out here. And then the other part is to find your asymptotes. Your asymptotes are going to always be at these odd multiples of every other pi over 2 absolute value of b. All right. You'll see how it works out real quick when we do a couple examples without the shift. Okay. So a tangent, like I said, a little bit different. The period of tangent is pi over the absolute value of b. And tangent has asymptotes to worry about. And those are at odd multiples of pi over 2. Let's look at an example. Jump right in. So I have y equals 3/2 tangent of 4x. Excuse me. First thing I'm going to do is I'm going to write down my a, my b, find out my period. My a value is 3/2. My b value is 4, which means my period is going to be what? Pi over 4. Good. So the period is going to end up being pi over 4. That means my asymptotes are going to be pi over 4 apart from one another. That's how long it takes to go between them. Very good. Wait.
pi by d.
That's when we're worried about these asymptotes. Okay? And when you start with your period with tangent, you know that the asymptotes, notice how I didn't put any numbers on here yet. I know that the distance between these two asymptotes is going to be pi over 4. Since I'm starting with this as the parent function, it's going to go through the origin. It's going to be symmetrical on both sides. So it's going to be an equidistant from the origin to the asymptotes. So if pi over 4 is the total distance, 1/2 is pi over 8, the other half is pi over 8. So your asymptotes then, if your period is at pi over 4, your asymptotes will be at pi over 2 times 4, which is at pi over 8. It's another way to write it out. I like using the logic part as opposed to writing the equation part out. I think it's a little bit cleaner, but to each his own. So the asymptote's at pi over 8 and negative pi over 8. Now think about when we plotted out the original tangent when it had the asymptotes at pi over 2 and negative pi over 2 with a period of regular old pi.
So would it be 5 over 16?
Very good. It's going to be half, these are always the halfway points of the asymptote and the origin. Well, what's halfway between pi over 8? Pi over 16. And then on the other side would be negative pi over 16.
So would it still be 1 to 1? Or would the points of the graph down?
Well, they would be, but now what's the a value?
3 over 2, so 3.
Very good. So instead of being at 1, it would be here at 3 over 2. And there's your curve. Whoa. Start that again. The a value is where that change is going to occur. So we're at negative pi over 16, 0, and all you have to do is, whoop, there it is. So when you go to write out ordered pairs here, my ordered pair would be at negative pi over 16 and negative 3/2. What's the easy one? 0, 0. And then the other one is just going to be the exact same ordered pair, just positive.
Could it be plus and minus?
No. Because it,
That's okay.
when you go to the shift, it's not going to be that
As
easy.
in save, just like the save time.
Oh, how hard is it to write pi over 16? I know it's difficult, but plus what'll happen when you have your shifts, it's not gonna be as clean because they won't be mirrored points because things will be moved up and around. They won't be the same. Okay. All right. That is how you graph a tangent. Questions on that? Let's shift it then. What do you think is going to happen with an h and a k? Same thing, horizontal and vertical. So you're going to plot the parent function, which is this, shift the h, shift the k, and replot. Now the weird thing is that when you're shifting it, what do you have to do with your asymptotes? Shift them. Now an asymptote, since these are vertical asymptotes, are they going to be shifted left and right or up and down? They're just going to be shifted left and right. Asymptotes, if you move them up and down, they're still going to be in the same spot. Yes, sir?
What happens if your a is negative? Would you do it that way?
Correct, yeah. If it's negative, if the a value is negative, that just means you're going the other direction. It means it's just reflecting going the other way. Okay. So let's do a shift. Well, we might as well write this out then. The shifted version of tangent looks just like the other ones. Y equals a tangent b x minus h plus k. You do the exact same thing as we did yesterday. We plot the parent function, write out the ordered pairs, shift the ordered pairs, replot. It's that systematic. And just like Russ was asking, if it's A is less than 0, instead of moving up and to the right, it's moving down and to the left. I think we have some dance moves we can do now.
You want this sheet?
Well, you should show us the dance moves. You're right there. I think Lena should do the dance moves.
Is there interesting answers? You make them yourself?
Somebody gave that to me.
Why don't you do that? You're the teacher, you have to show us.
But he's the teacher, exactly.
Make your arms move like a sine curve.
I can't do that.
Anyway, we'll do that later. That was well played. Both of you guys didn't synchro. Let's do this, and let's tack on a K for fun.
Yay, fun. Fun. I like the crowd.
I like that one. That was my favorite one. All right. Again, so what happens here, guys, is that whenever you have this to start out with, what you're going to do is just like we did yesterday. We're going to label out our A, B, H, and K. After we do that, we're going to identify, since it's just tangent, there's really no amplitude. So we're just going to identify what our period is.
So it's
Well-
gonna be
Well, let's start with this. What's A?
-2.
-2. What's B? Good. H?
-pi/2. -pi/4.
Yeah. Yeah, -pi/4. And then K is a +3. So I know that when I'm done graphing the parent function here, everything's going to have to move left and up. Everybody okay with that? All right. Our B value is 1, so what is our period going to wind up being for this? Just plain old boring pi. So let's start this. We know that the period is at pi, which means where will my asymptotes be placed for the parent function? Good. Plus and minus pi/2. Very good. I also know that my next important points are going to be halfway between pi/2 and 0, and -pi/2 and 0. Those are both at good. Plus and minus pi/4. My A value is -2. So is this one increasing from left to right or decreasing? Decreasing. When it is at pi/4, is it going to be at 1 or is it going to be at a 2? Remember, this value here tells you that at your pi/4s, at the midpoints between the asymptotes there and the origin, it's going to be occurring here. Since it's decreasing on its way down, that means when it's at -pi/4, it'll be at a +2, 0, and -2. Okay?
That's not shifting.
No, we always start with the parent function. My ordered pairs for the parent function then are -pi/4, +2, 0, 0, and +pi/4, -2. One of the tricks for graphing with tangents is the fact that you already know that you're going through the origin. So that usually means that the easiest place to start your shifted ordered pairs is to use the ordered pair of 0, 0. When I'm shifting this, I know I have to move everything to the left, pi/4, and then up 3. So the new origin for the shifted graph will be where? It'll be at -pi/3. This is going to shift to negative pi over 4 and 3. Are we okay with that? Now, when I go to my other shifted point, what's negative pi over 4 minus pi over 4? Very good. This becomes negative pi over 2. And what's 2 plus 3? All right. My other shifted point is at pi over 4 minus pi over 4. 0. Negative 2 plus 3? A number. I wrote it down. Lastly, yes, sir?
Are we gonna have to graph that?
Yeah. You'll see it's not that bad. Once you get the ordered pairs in there, the next,
Now I have to make the graph bigger and stuff.
yeah, you get used to it. You know, it's just one of those things. And I'm with you. My graph is not going to fit nicely either. When I move this one over, I have to move my asymptotes. If I move my asymptote pi over 4 to the left, where does from pi over 2, where does it go? What's pi over 2 minus pi over 4? Pi over 4. What's a half minus a quarter? A quarter. So everything's just, this just moves over to here. So your new asymptote is here. This one from negative pi over 2 goes to negative 3 pi over 4. Everybody okay with that? I just moved it over a quarter. Notice the period here between negative 3 pi over 4 and pi over 4 is still pi. The period doesn't change. It will always stay at pi. Oh yeah, it's Wednesday.
Yeah, we have 6, 7 minutes.
No, we got fine. We're almost done. The rest of these ordered pairs I think are already set into our graph already. We just have to tack on a couple of extra y values. So we got 3, 4, and 5. Negative pi over 4 and 3. And 0 and 1. And there's your shift. Obviously, when you have your shifted graph, the points may, in fact, lie upon the parent function asymptote. It's not a big deal. It's not a big deal. All right. If you happen to have two different colors for tangents, it might be helpful, just because it can get messy with all the asymptotes and stuff going on in there. But again, what I want you to be able to do, is write out your ordered pairs and relabel your new asymptotes, and you're going to be okay. All right? Questions? Let me give you a couple of these to try. Really?
Well, I like this. I like the whole graph.
Oh, okay.
What do we do?
Let's do. You know what? Let's just do shifted tangents. You have to graph the parent function anyway, okay? Is that okay?
Yeah.
All right. So this is section 14.2, page 845. Do 44 through 49. There is a trick on number 49 that you need to figure out.
Oh, yeah, too much.
It is a conundrum, yes. There is a trick. So there's 6 tangents. Give it a shot. I think it'll be all right. Okay? We'll tie all this stuff up together. Tomorrow, we're still going to quiz on Friday. There's no reason to move it ahead. I mean, we could if we really wanted to, but it's not that big of a deal. That'll give us time tomorrow. We'll probably just do a couple extra of these graphs in class. Answer any questions, call it a day.
So the quiz is just 14.1 and 14.2?
Yeah, it's just going to be graphing. It's just going to be straight graphing on the quiz. I'm not going to have you guys write the equations out. Okay?